this packet tracer, we have a topology where we are going to implement a router on a stick in order to be able to route between the VLAN 10, 20, and 30. So we have these three VLANs right here, and we need to be able to communicate with each and every single VLAN and route between these VLANs. Now, again, the implementation will be a router on a stick, configuring the sub interfaces for that router. Now, if we take a look at the instructions, so we have our addressing table here at the top. We have our VLAN and port assignment table. We see VLAN 10 is being assigned the faculty, staff, and 20 for students, 30 for guests, which will be the default, 88 for native, and 99 for management. Very well. We will, in this activity, demonstrate and reinforce the ability to implement VLAN routing, including configuring IP addresses, VLANs, trunking, and subinterfaces. Our instructions are straightforward. We will configure the devices to meet the following requirements. Assign IP addressing to R1 and S1 based on addressing table. Configure the default gateway on S1. Create, name, and assign VLANs on S1 based on the VLAN and port assignment table. Ports should be access mode. Your VLAN name should match the names in the table exactly. Configure gigabit 0/1 of S1 as a static trunk and assign the native VLAN. All ports that are not assigned to a VLAN should be disabled. Configure inter-VLAN routing on R1 based on addressing table. Verify connectivity R1, S1, and all PCs should be able to ping each other and the server. Okay, let's go back and let's work with that first instruction, which is assign IP addressing to R1 and S1 based on addressing table. So we go to R1 and we'll take a look at the interfaces. What is the status of that router interfaces? With the show IP interface brief, we see we have gigabit Ethernet 0/0 up and up with this IP address. Okay, and we need to configure gigabit 0/1 with the addressing. Now, as we know, we have these VLANs 10, 20, 30, 88, and 99. 88 will be the native, and 99 will be the management. 10 faculty, staff, 20 students, 30 guests. Default. Okay, so for that we have the sub-interfaces for each and every single VLAN. Now what we need to do is going back to the router CLI and configure the appropriate addressing and configurations on that interface or sub-interfaces. So let's go ahead and configure terminal. And let's first go with the VLAN 10. See if I can make use of okay, right here. All right. So first sub-interface. Okay. For the VLAN 10 interface. we have to go to configure terminal. Okay, interface gigabit 0/1 dot 10. That will be our first, and then we go there. Description is going to be for faculty and staff. Okay, very well. Now we are going to also then the encapsulation protocol for that VLAN, which is 10. Okay. Now we can then assign an IP address. For 10 is going to be 172.168.1.1. Paste that there. And the 255.255.255.0. Okay. Get a node shut down. Very well. Now let's go to the VLAN 20. Sub interface for that VLAN. The description will be for students. I like to add descriptions for ease of troubleshooting later, because it's going to happen eventually. Alright, encapsulation. Encapsulation. Okay, if I can type. So that's VLAN 20. Okay, IP address 172.172.1.21. Paste that there. 255.255.255.0. No, shut down. Okay. Now let's repeat for VLAN 30. Interface. Okay. Description. Guest default. Encapsulation for VLAN 30. Okay. IP address. Okay. Now it's shut down. Repeat for the rest of the VLANs. IP address. Not shut down. Okay, 99. Okay. Description. Management. encapsulation 99 IP address. Alright, copy that, paste it there. Subnet mask. There we go. And then shut down. Okay. Alright, so router 1 or R1 has been configured with the IP addresses for those VLANs. So it's gonna act as the default gateway for each and every single VLAN in this table, and it's going to be then providing, yeah, the default gateway, and we'll be able now to route between VLANs. Okay, so sub interface has been configured. S1, we need the management because that's really the only VLAN that we need, or not VLAN, but the only IP address that we need there just for management purposes. So we go to switch 1, and we're gonna go to the first, we need to create a management VLAN. So since we need to create the VLANs first, I will go ahead and then do that right here, since we are already, let's see, configure this one. Yep, so let's go ahead and do that. Okay, so let me create the VLANs first. Now let me just take care of that. Terminal. All right, VLAN 10. Okay, name. Okay. All right, faculty and staff. All right, paste. Okay, VLAN 20. We're gonna name that students. Okay, VLAN 30. Name guests. Default. Parenthesis default. All right. VLAN 88. Name. That will be the native VLAN. So there. And VLAN 99, which will be name management. Okay, I think we got that done very well. Okay. Now let's go ahead and create the interface for management. Actually, let's do show VLAN brief. Okay, and here are the VLANs that we just created. And every single port right now is being assigned to VLAN 1. So although all these VLANs has been created, they're not working at all, right? So because every single uh, port of the switch is still being connected to the default VLAN 1. Okay, but we're gonna change that. But first, let me just get out. Okay, and create the management interface, which is going to be interface VLAN 99 for management. And we're going to apply the IP addresses. IP address for that, which is this one right here. Okay, so IP address. Okay, very well. And that's all we need to do here uh, when it comes to applying IP addresses. Okay, now we are going to exit and assign the default gateway for this switch, which is router 1. Is going to be, what will be the IP address for that? Is going to be, okay, very well. All right, 99. Okay, 99.1. That will be our default gateway. So, uh, default IP default gateway. That's it. So we need. Fantastic. Good, good. Then next, let's assign the ports. Okay, we already created the VLANs. Now, for VLAN 10, we're going to use, let's see, okay, okay, from 6 to 10 is going to be the guest. Okay, VLAN 30. All right, so that will be from Fast Ethernet 0/6 all the way up to 10. Anything below that should be then uh, disabled. All right, for security purposes. So interface range fast 0/1 through 5. We're going to shut it down. We are going to shut that down. Okay. Then from 6 to 10, Okay, is going to be access. So switch port mode access, switch port access VLAN, and we said will be VLAN 30. VLAN 30. Okay. Okay. Now faculty slash staff, which is VLAN 10, is going to take the range between 11 and 17. Okay, so switch port mode access, switch port access VLAN 10. All right. Then from 18 to 24 will be VLAN 20 for students. All right. From 18 through 24, switch port mode access and switch port access VLAN 20. Okay. All right. So we have all the interfaces. Gigabit. All right. Let's see the rest of it. Let me go ahead and do show IP interface brief. Okay. Down 6 to 10. Okay, from 6 to 10, that's gonna be VLAN 30. Okay. Very well. Okay. VLAN 1 is down, which is good. Gigabit 01 and gigabit 02. Okay. Giga 1 is going to be for the new native, which is VLAN 88. Okay. Exit here. Interface gigabit 0 slash 1. Alright. Switch port mode trunk. Switch port trunk native VLAN 88. Okay. And then gigabit Ethernet 0 slash 2 should be shut down. Okay, very well. All right. Table, continue to table. Okay. All right. So now let's go ahead and we have all the VLANs, I believe, assigned. Okay. And we have the trunk. Shut down. Let's go now to the router and turn that on. Okay. Gigabit 0. Let's see, do show IP. Gigabit 0/1. Um, let's give it a no shot. Should come up now. Let's see. Coming up. Okay. All right. So PC1. 10. Okay. That's good. Let's see if I can bring the address in here. PC1 is 21. It's good. PC2. Okay, let me bring this on the other screen. Okay. PC2 should be 1720.22. Okay. Default gateway is correct. Let's see PC3 30, 31. Huh? Okay. So let me try to ping, copy this PC3 from PC1. Okay. Testing the ping. Some ARP. All right. Success. Can I ping the server? Let's see. Okay. All right. After some time for ARP, we were able to ping the server from PC1. From PC2, can we ping the server? Yes, we can. And let's try from PC3. Yes. Okay. All right. So it looks like we have connectivity across the uh, topology. However, we are missing some type of configurations here. Looks like the native VLAN, okay, is not correct. And that's because I did change. I need to send the VLAN on the router. Okay, so we're gonna go ahead and 1.88. Okay, and we're going to encapsulate 88 native. All right, and that should take care our packet tracer error. Let's see if that makes sense now. Let me bring this over here. And indeed, it looks like now it's not showing all the errors. Okay, so congratulations, you have finished. Okay, very well. So that was the packet tracer challenge for routing between VLANs. I hope this will be informative and helpful for you. See you on the next.